So can someone tell me what is the definition of group? Definition of group.
Sir, group is a non-empty set G together with an operation O.
Whether
And
screen is
in
visible? My
this,
screen is visible to everyone?
not yet.
Okay, I will share my screen.
And in the group, four properties should get satisfied, like closure, associative existence, and existence of inverse.
Okay, so I write down again a definition for you for a revision purpose. So we are discussing group. Okay, okay. So yes, tell me, what is group?
A non-empty set G
Okay, so G is non-empty.
together with an operation O.
So we can define any operation. Okay, so with
Yes.
operation, so we call as that operation like that only. Okay? This is nothing but my operation. Okay, yes, tell me now.
Okay. And
Number
then
one,
closure property.
G and this, or it is algebraic structure. Okay, it is called an algebra. When it is algebraic structure, when 0 is binary on G. And in other words, we can say that one dash, that that operation, whatever the given operation, is closed on G. What is meaning by closed, or what is meaning by binary?
Sir, I think it satisfies the condition like A is close to B belongs to G.
Okay, so I can take any two elements from a set G, because G
Like
is
that only,
non-empty,
na,
no?
sir?
Yeah, that only. So if you take any two elements, A and B, then this implies if I operate that operation, whatever that operation we have defined, A, O, B, that O may be anything, huh? Anything. They will define at the time of example, we will define that O. That whatever the answer I am getting, that answer also belongs to G. If this happens, then that operation O is closed on G. Everyone understand that? Clean and clear?
Yes,
Yes or
sir.
no?
Yes.
Anyone, any doubts here in the closed one? What is second property? And it is also called as sometimes a binary, because whenever we discuss an algebraic structure, that time we discuss it is binary operation. Why binary? Because we require two elements, and if I make that operation on two elements, whatever the result, that result also belongs to G. That is what the meaning of the binary. Okay,
Means
what
two
is next?
elements A and B belong to G, right?
No, like that only. See, if you have, you can take, suppose G is nothing but the natural numbers, and you can take any two elements from the natural numbers, any two elements. Take
Hmm.
your number and your parents' number. Okay, and my binary operation suppose is plus. My binary operation is plus. So your
Hmm.
parents' number and your number, if you add that two numbers, whatever the result you are getting, whether that result belongs to natural number.
Okay.
Definitely it is no, because you can take any big 10-digit natural number, another 10-digit natural number. If you add that two natural numbers, you are getting some digits natural numbers. Okay, and that natural number is also belongs to a natural number. So that time that plus is the binary. What about minus? What about minus? If I consider my G is equal to natural number and my operation is equal to suppose subtraction. So whether that subtraction is binary or natural number, whether that subtraction is binary or natural number. Yes, anyone? You understand my question?
That minus is binary or not? It is.
Yes, it is binary.
Yes.
Okay, okay, someone is saying no. Just can you please tell me why it is not?
Because if we take two elements such that 2 and 3, and 2
Okay, I
minus 3
can
is
take
minus 1,
2
which
and
does
3
not belong to
belongs.
natural.
Correct, absolutely correct. That n stands for natural number. So I take 2 and 3. Whether 2 and 3 belongs to natural number? Yes, absolutely. I operate now that 2 minus 3. What is 2 minus 3? I am getting minus 1.
Minus.
Whether that minus 1 belongs to natural number? Not. Minus 1 is not belongs to natural number. So that subtraction is not binary on G.
Okay.
So you can write down minus is not binary.
Sir, but in case of real numbers, we can get like you gave an
Yeah, yeah,
example.
yeah. If you change the set, then it is okay. No, so that's why we called here G is non-empty with operation O. Right now,
Okay.
I'm interested on G only. If my G is the natural number, then this what I'm saying, natural number together with the minus is not binary, or which is not close also. Binary and close work on the same line. Whatever the definition we have for binary, the same definition we have for the closed one. I think everyone clear with this now. Yes or no?
Yes,
Yes
sir.
or okay. Any doubts? Okay. What is next one? What is next property? You can take any three elements A, B, C belongs to the given set G, and if you find out A into B into C, you can write down A into what is this property? What is this property?
Associative.
Associativity. So first one is closed or binary. You can say that this is the first one. This is the associative. What is third one? What is third one?
Existence of identity.
Now tell me how. What is existence of identity? So
Sir,
for all A belongs to the set G, there exists some E which is also belongs to a G. See, huh? That A is also belongs to G, and E is also belongs to G. For all A belongs to G, there exists a E which is belongs to G such that, tell me, such that
A dot E is equal to E dot A.
that dot is operation, okay,
Okay.
which
Okay.
is equal to E, and E dot A is
Is equal to
also,
A.
oh, sorry, A, yes, yes, absolutely correct, A, not identity. It's identity element, it means it is E, correct, good. So you have attention here. So it is A, and it is also E. So the E for all A, you can take any element from the set, any element, and if you find one element E, that element we called as that element as an identity element.
So then if we want to classify whether this property is identity or close, so for identity we need to remember no, that the condition should be that answer should come as A.
Yes, because you can take any element from the set, and if you do the operation, whatever the given operation we have on that element, and if you are getting the same element for all A, for all A, it means suppose you consider the natural numbers and you take addition. Okay, natural numbers and addition. Can you find any element? For you can take any element, suppose X, Y, Z, one element. If you add something into one, you will get one. Can we have such a numbers in the natural one?
Yes.
Which one?
Natural number.
If I have one element, or I can say 5. If I add 5 belongs to natural number.
Yes.
So 5 plus something is equal to 5. What is that something?
0.
But whether 0 belongs to natural number?
No.
No. So it does not have that. The identity element is not exist in the natural number with respect to addition. But if I take a Z, Z is nothing but what? Set of integers.
Integer.
So in the
0 is
integers,
integer.
Yeah.
yes. So for 0, it is satisfied. Got it?
Yes, sir.
Got it, everyone? Anyone, any doubts? Can I go further now? What is next property? Fourth one,
Inverse.
inverse. Tell me now, what is inverse? So I can write down the fourth one, inverse. For all A belongs to G, there exists A inverse, which is also belongs to G, such that A, that operation into A inverse is equal to identity, which is equal to A inverse into that operation operated on E. What is that E? E is nothing but your above identity element. Clean and clear now this operation?
Yes, sir.
Okay, if any set with the binary operation satisfy that 4 conditions, then that set or that structure we called as a group. Then you can write down here, then G into that structure, or we can say that algebraic structure. You know what is meant by algebraic structure?
Yes, sir.
What is meant by algebraic structure? That algebraic is group. If either of one is not satisfied, then it is not a group. Clean and clear?
Yes, sir.
Everyone understand that? Anyone any doubts here? Anyone any doubts? What the group? So for saying a group, you should have that 4 properties with you. Okay, I just check whether my recording is on or not. Just give me a minute. Yeah, it's working, no? Yeah. Okay. Everyone understand now group? Now we have, in the last lecture, we have given some examples to you. You need to say, you need to check whether these are group or not. So let's see. Okay, tell
Sir,
me.
you gave this example from this Z comma plus.
Yeah, okay.
with
We just
integer.
let's take this example only. Okay. So example number 1. What I am talking about? Z comma plus is group or not? Am I correct? This is what the example you are talking about?
Yes.
Okay. So tell me whether it is closed. What is meant by Z? Z is nothing but what? I just mentioned here. Your Z is
Integer.
nothing but set of integers.
Yes.
Set of integers. Okay. So tell me, what about first property? What is our first property? Closed. So tell me, if I take any 2 elements A and B belongs to Z, okay, whether this implies A plus B also belongs to Z. Whether this satisfy for all A and B, you can write down for all A and B belongs to Z. Whether this condition is satisfied.
Yes,
Yes,
sir.
sir.
If it
Yes,
is
sir.
not, suppose someone is saying, sir, not, it is not satisfied. Then give me the example. In the problem session also, or while solving the problem also, what you need to do, if it is satisfied, then you can write down like that only. For all A and B belongs to Z, A plus B also belongs to Z. Okay, you can write down. If someone is saying, sir, it is not, close one is not satisfied, then give the counter example. Give the counter example. But here the counter example is not possible because this condition satisfy all. Okay. What about associative? The first condition is satisfied. What about associative? What is associativity? For all A comma B comma C belongs to Z, we have A plus B plus C is exactly equal to A plus B plus C. Yes or no? Yes or no?
Yes.
You can take it, you can take any 3 elements, minus, plus, any 3 elements. If you add first 2 elements and then add third element, you will get the same thing. Okay, you will always get, because if it is closed, most probably, most of the time, if the plus operation is closed on the set, then the same operation is associative also on the same set. Okay, so I just write down here, then this implies plus is associative on set of integers Z. I can define Z like that. You can define in your way, no problem. Okay. Now the important one. What is third one? What is third? Third property?
Inverse. So yeah, identity.
Yes. So whether the identity element exists or not.
It exists, sir.
Okay, just give me a minute. Huh? Okay. So
Sir,
how?
means if the answer comes as A, then it is confirmed identity element.
For all elements, what is our condition? See, what is our condition for all A? So you can take any
A
element.
belongs to G.
G is, what is G here? Z.
Yes.
For all A belongs to Z, there exists. Yeah, which one you are saying identity element here?
I'm saying that if identity element will only come if the answer is A for
Yes, exactly. What, that is what the definition of identity element. No, if you do the operation on the any element from the set, you will get the same element. Okay, got it. So tell me, what is identity element here? Anyone?
Zero.
Zero. So there exists a zero, but you need to observe whether zero belongs to that set.
Yes.
So 0 also belongs to the integer. So for all A belongs to Z, there exists 0, which is also belongs to Z, such that you can add 1 plus 0 or A plus 0, you are getting A, and 0 plus any element, you are getting that element itself. Whether this is true for all the elements?
Yes.
Yes. Okay, this
Yes,
is
sir.
true. So this implies 0 is nothing but your identity elements. So 0 is identity element. Or you can also write down your E is nothing but your 0. So identity element is also exist. Whether the given set algebraic structure is closed, yes. Whether it is associative, yes. Whether identity element exists, yes. What is next now?
Inverse.
Inverse. So the fourth one, no?
Yes.
Inverse element. So now for all A belongs to the Z, there exists now whether, tell me, for every element of Z, the inverse element is there or not? If it is
Yes,
there,
sir.
so tell me what is that inverse element?
So negative of A.
Negative of A.
Negative of that integer.
Correct. So I just write down here for all A belongs to Z, there exists minus A, which is also belongs to Z. You need to check it out whether that minus belongs to Z or not. Such that, yes, tell me what is such that? A plus of that minus A is nothing but your identity element, which is nothing but 0. And minus A plus that A is equal to 0. What is that 0? 0 is nothing but your identity element. And this is true for all A. You can take any element in Z. You can take minus 99. So there exists a 99. There exists 99 such that 99 plus or minus 99, you will get the identity elements. So tell me whether it is group or not.
Yes,
It
sir.
is.
So it is group. So can I write down it is group then? So this implies, you can write down this implies algebraic structure Z with the plus is group. Everyone understand group now? Can I give you one more example? Can I give you one more example?
Okay, sir.
Okay, the simple example, very, very simple example. Let's see whether you are going to solve or not this example. The second example. Real number with usual multiplication. That dot is nothing but the multiplication, a usual multiplication. So real, or we can say that set of real numbers is group or not. That is set of real numbers with that you can say product also is group or not. What do you think, whether it is group or not?
Yes, it is.
It is
Yes, sir,
group.
it is.
Okay, okay, very good, very good. Someone is saying it is not a group. Anyone that comes in your mind, it is not a group. Anyone is not there?
Sir, for inverse, I'm not sure whether it satisfies the question or not. Sorry, the condition.
Okay, okay. What is that fourth condition for the inverse one? Okay, okay. You are very closed. You are very closed. You need to think now. You need to think. You need to find out that number such that the inverse of that particular number is not exist. So let's see. Let's see what happened. What about closed? What about closed? Whether it is closed?
Yes, sir.
It is closed. You can take any two numbers and do the usual product 3, 5, 5 3 are 15, which is also belongs to the. You can take an integer, you can take the rational number, you can take the irrational number, do the product. It is also a part of R. R is nothing but the set of real numbers. So it is closed. I'm not going to write down. Now you know how to write down. How for all A and B belongs to R. This implies A into B also belongs to R. Therefore, that dot operation is closed on R. Associative. What about associativity? Tell me whether it is associative or not.
Yes, sir, it is.
It is associative, so I'm not going to write down. You just all people just write down how we can write down for associativity. Okay. Now the third one. What is third one?
Identity.
Identity element. Tell me what is identity element here?
1.
1 is the identity element. So E is equal to 1. Whether it is true?
Yes, sir.
How? So for all A belongs to the real numbers, there exists the identity E we called as 1 such that that 1 is also belongs to R, real numbers, such that 1 into A into that element you are getting the same element, and that element into 1 you are getting the same element. So 1 is the identity, correct? So identity is also there. What is next?
Sir, can you tell identity element? I didn't understand that E is equal to 1. How
Okay, okay, okay. Tell me, what is your operation is my
dot
dot is nothing
multiplication.
but multiplication. So in the real numbers, take any number, multiply that number to something, you will get the same number. What is that something? Take any number, take your mobile
Okay.
number. Your mobile number into, if I multiply by some number and you are getting the same number. So what is that number?
1 only.
1 only.
Okay.
Okay, and this is true for all numbers. This is true for all A. All A belongs to real numbers. Here we have mentioned it. All A which is belongs to real. Okay, got it now? So that's why
Yes.
this is identity element. Okay, these what we are saying, these whatever the groups we are, these are the infinite groups. Whenever comes in the finite group, that time I will tell you how to find the identity element and everything. We are like these are the special kinds of groups, because natural numbers here, these are the universal sets, no, very well known sets. That's why these are the standard element identities one. Or you can do also like that also. How you can do, you can take A into some B. Suppose B is nothing but my identity. I am getting A itself. So what, this A get cancelled, you are getting B is equal to 1, that B is nothing but my identity. Like that also you can do. Got it? Yes or no? You didn't understand that? That B is
Yes,
how,
understood.
yeah. Or you can write down A into E is equal to A. Into is your usual. So you can also, E is nothing but A divided by A. So E is equal to 1, you are getting like that. You can find out in that way also, no problem. I just erase that one because this is not required. This is for understanding purpose. In examination, you just write down E is equal to 1 is identity element. Why? Because for all A belongs to G, whatever the given set R, there exists a one also belongs to that particular set, such that this condition, that both the condition are satisfied. Okay, forget about that now. Now the third one, what is inverse? Tell me now, what is inverse element of A? What is inverse elements of A?
Will be E only.
A only?
E.
A.
E. I say E.
What is definition of inverse? I write down the definition of inverse. For all A belongs to the set R, there exists A inverse such that, which is also belongs to R, such that A into A inverse, that into is nothing but your product, is equal to identity. If you
Sir,
are saying
E only, yes.
if you are saying 1, so suppose let I can take my A is equal to 10, and you are saying your A inverse is equal to 1. So this implies what 10 into 1, you are getting 10, not identity element. Here you what I want? Identity element. So this is not true.
So it will be 1 upon 10.
1 by A. Yeah.
1 by A. Okay, 1 by A is the correct one. But for all A, it is true. For all A. So now for
Zero.
if 0 belongs to real number, if 0, whether 0 belongs to real number,
Yes, sir.
0 is the real number, no? So when 0
Yes.
belongs to real number, then what is inverse of 0?
Sir, not defined.
Not defined means what?
1 by 0.
1 by 0 is mean what? Whether it is there?
Infinity.
Infinity. What is infinity? Is a number. It is the largest term. It is not a number. So when 0 belongs to real number, then we don't have its inverse. So inverse element is not exist for 0. So whether it is group now?
No, sir.
No.
No. So then what we are saying, R, comma usual product is not a group. Clean and clear to everyone? Just because of that 0, it is not a group. Clean and clear?
Yes.
Okay. Now write down the remark.
Sir, means for inverse element, we should get E only, right?
Identity element. Any number into that inverse should be identity element. Then and then only it is called as a inverse.
Okay.
Got it? Write down
Yes.
the remark now. So we define new set. I define here R star, which is non-zero elements of R. That is R star is equal to your all real numbers minus singleton 0. Is it okay now? Now tell me, whether R star with usual product is group.
Yes, sir.
This group, yes or no?
Yes, sir.
Yes, sir.
Definitely. Why? Because close property is there, associative property is there, inverse. What is your identity element? What is identity element for R here?
One,
In that
one.
one itself, identity element remains same. And what is inverse? So inverse of each element is exist. Then what is that inverse? What is a one? What is the inverse of A? It is 1 divided by A.
Yeah.
0 is not the case because that set does not contain 0. So for all the elements, we have inverse element also. So answer is yes.
Sir, means in this case for inverse, it is
Yes.
R, right? For this case, it is R, right?
R, what I'm not getting R. What you are trying to say?
Means for inverse, you said something, right?
What inverse? So for what is the definition of inverse? For all A belongs to R star, there exists 1 divided by A. We called as A inverse, which is also belongs to R star, such that A into 1 upon A, you will get identity element. What is identity element we have? What is identity element of R star dot?
1.
1. So you can see this 1 get cancelled, you will get 1. So this condition is satisfied for all elements. Initially, we have problem with the 0. So we remove that 0 from that R and we define a new set we called as R star, like that. Got it, everyone?
Yes.
Clean and clear. Anyone, any doubts here? Any doubts? Can I go further?
Yes, sir.
Yes, sir.
Any doubts, anyone? Write down the next example. Example number whatever you have, third or fourth. Okay. Tell me whether Z star. What is meant by Z star now?
It doesn't include zero.
Z minus 0.
Z minus 0 is a group.
No, sir.
Huh?
No.
Why not?
I didn't. Oh, it's a product now. Yes, sir. It might. Yes.
It may not be what you are trying to say. Tell me. Yes, just think on that, whether it is group or not. Yes or no? Yes, please tell me. And why? Tell me.
Sir, it is not a group.
Very good. Why it is
Not,
not a
sir.
group?
Sir, because
Sir,
the
for
inverse
inverse.
does not exist.
Correct. Correct. It is not a group. Since A inverse not belongs to G star. So you can take for one example, that is if 3 belongs to G is nothing but star, then we don't have A inverse of 3, such that 3 into that A inverse is equal to, what is identity element here?
1.
1. So you cannot find A inverse. Why? Because A inverse becomes 1 divided by 3. But 1 divided by 3 not belongs to G star. Please mute yourself if you have someone is, I don't know who is that person. Okay, thank God. Thank you. So everyone understand 1 by 3 is not belongs to G star, it is not a group. Clean and clear?
Yes, sir. G star means this, no?
Oh, sorry. Here instead of G star, which is nothing but your Z star. Just mention here Z star.
Sir, means
When-
is it the opposite like of Z or what?
Not just the not element. Zero is not there only. Not opposite and not like that.
No,
Its
Z
star means
star.
what? Z star means all the elements of Z. Just zero is not there.
Okay.
Zero is not there. Star means what? Zero is not there. Just like an R star. We define R star above, no? Yeah. What is R star?
It
All the
means all
elements of
real
R.
numbers except 0.
Like that only Z star there. Okay. So star is nothing but we are not having that even. Now, next example, the example number 4th, 5th. Tell me now whether Z plus is a group or not. Z plus is group or not? Tell me. Z star plus is group or not? Tell me now, 2. And we have to give the reason also.
No, Sai, because for inverse again, we have to use the negative term. So negative integer does not exist.
Negative integer does not exist in Z.
It
Exists.
is group.
No, Z plus,
First
Z
one.
plus.
It's
You are talking
star.
about first example, no? This example you are
Okay,
talking
oh.
about. Whether it is
No,
group
no,
or
I was
not.
talking about the second one. No, I was talking about the second one. Sorry.
Okay, but let's first discuss for the first one. Yes, tell me. Z plus
Okay,
is a group
sure.
or not? Z plus
Yes,
is a
sir.
group or not? It is group.
Group.
Yeah.
Okay.
Yes.
Yes, sir.
Group. All properties are satisfied. What is the reason? All properties are satisfied, or all properties done. What about second one? What about second one?
It is not so, because in the inverse part, the negative would be there. So Z plus is not it does not
Inverse is
satisfy the
satisfied,
negative.
but identity is not.
Yes.
Yeah.
Does not have
Identity.
identity. If it is not have identity, don't go further for the inverse one. Okay. Does not
Okay.
have identity. Because 0 is the identity, no? And we remove the 0. Once we remove the 0 means what? Means nothing is there. Got it? Now the third one. Natural number with plus. This is natural number. Natural number with plus. Group or not?
No.
Why it is not?
Identity element does not exist.
Identity not satisfied.
Negative number we will have to use.
Yes. So same reason. The identity element not exist. Very good. Is the fourth one. You can take real numbers with plus. Real numbers with plus.
Sir, it is a
It is
group.
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 It's a group.
Okay, group.
Yes, sir.
Correct. It is group. The fifth one, real numbers with subtraction. Tell me.
It's not a group.
Why?
Associative property, I guess.
Associative is satisfied. You can take any three numbers, make a subtraction, definitely it will satisfy. Just check it out. Just
Then
tell me that.
inverse.
It is a group. It is a group, sir.
Okay, someone is saying it is a group. Actually, it is not a group.
Because inverse is A itself. That's why it cannot be.
Someone is saying associativity. So I'm also a little bit, worried about. Just tell me, can you have any example with associativity? Any three numbers and associativity? Just check it out. You are very close. You can take any example, -3, 2, and -1. So first I do -3, -2, and this minus of -1. What I am getting? I'm getting -5 plus 1, that is nothing but minus.
-4.
And what I'm going to do here, -3 minus of
-2 -1.
minus of -1, no? Like that, no? Am I correct? These are the numbers, no? We have to get this, not, this is not there.
Sir, extra minus was there. Yeah.
Yeah, it's correct, no? If I remove that 2. So -3, that minus, that second number and minus. So what I'm getting, -3 of minus, and I'm getting here 3. 2 minus plus 1, so 3. So I'm getting something -6. Am I correct?
Yes, sir. So that is
Yes.
what's the group.
Yes, it is not a group. Correct. Also, that is correct. That is you associative. You just stuck with the associativity. That is the correct one. But you also have one more point for identity element. What do you think? What is the identity element? Forget about suppose this. What should be the identity of this?
Yes, sir. If the second condition doesn't satisfy, there's no need to go for the third
Yes,
condition.
definitely. Absolutely agree with that. If suppose I wanted to describe a new point. That's why.
Yes, sir. Okay.
So suppose let us assume any identity. What do you think? What is the identity?
0.
0 is the identity. Absolutely correct. So what is identity element? So A minus 0, you will get A. And 0 minus A, what you are getting? Minus
So
A.
it's A.
Minus A.
Yeah, exactly.
Not A. So that's why identity element is also not existing. Are you getting my point?
Yes.
Yes, sir.
Okay, this is also now inverse also there. For inverse also, you can find out inverse may exist, may not exist. That is not the case. But if identity element is not exist, so that is also one reason you can write down. Okay, that identity element. Got it? No, everyone. That is what I wanted to say. That sometimes one property
Sir?
is satisfied, but second one is not. Yes.
Sir, and if you want to give the reason, then we can give it like this, no, that
This example,
identity and inverse property doesn't exist.
you can give at least one reason.
Okay.
Just you can say associativity is not exist, therefore it is not a group. You can say inverse element, identity element is not exist, therefore it is not a group. That's it. No need to give 2 or 3 examples. For giving it is not a group, just one condition is sufficient, which is not there. But if you wanted to show it is a group, all 4 conditions should be there. Got it? Now,
Yes, sir.
I hope everyone understand that.
Yes, sir.
Okay. Now these all are the infinite groups. R is infinite set. It means it is infinite group. Now let's see the example called the finite group. So I just write down the next example number. I don't know whether it is 5, 6. So suppose my V is the group. V contains 1, -1. I, what is I? You know that. Minus I. Where I is equal to square root of -1. Is group or not? Yes. Now the interesting part comes. For infinite group, for known set, we know that with addition is a group or not. I just need to write down V is equal to not is equal to. I just forget give the V with usual product. V dot is a group or not? Forget about this. Okay, V is given this, where I is equal to this. Then V with usual product is a group or not? Now tell me how one can find this. Yes, tell me how one can find this.
So it is a group, I guess.
Oh wow. What is identity element?
Identity element is 1 because it's
Okay.
multiplication.
What is the inverse of one? What is the inverse of -1?
-1.
Okay, what is the inverse of I?
-I.
What is the inverse of -I?
I.
Oh. What is the inverse of -I?
I have got
Okay. So it's correct. It's correct. It is a group.
I.
Absolutely. An identity element is one. So how one can show that? So for showing that, you need to draw a table. So what you need to do? You need to use here dot whatever you have operation and make a one table. So here write down first element 1, next element is -1, then next element is whatever you have I, and next element is -I. Okay, and write down the same elements here also. Here 1, here -1, here I, here -I, and do the product now. Now tell me what is 1 into 1? You are getting 1. What is 1 into -1? You are getting -1. What is 1 into I? You are getting I. What is 1 into -I? You are getting -I. Yes or no?
Yes.
What tell me that here what I am getting here?
Sir, first it will be -1,
Okay.
then 1,
Oh, very good.
then -I,
-I, very good.
then I,
Then I only.
I,
What is next here?
then I -1.
-I, no, I think.
Yes, sir, sorry, -I.
-I. Here,
Then I square
I square is what?
-1.
Very good.
Then it would be +1 because minus I square.
So you are getting I into -I. So you are getting -I square. So
Yeah,
you are minus of what you are getting?
-1
Minus of -1. That is you
is
are getting 1.
+1.
You are getting 1. Okay. What is next?
Then next one is a -I
-I
+1.
plus I.
Oh, so plus I. Then again then 1.
1. Very good.
Then minus into -1. Yes.
Yes. So now see. Now what about closed? So you can see these are all possible product I have done here. So you can take any two elements and its product, whether you are getting anything apart from that group, what are all that values 1, -1, I, -I, whether you are getting anything apart from that group.
No.
So you can see you will get 1, -1, I, -I. If you do any product, you can take any two numbers and do the product, you will get the same number. So whether it is closed,
Yes.
it is closed. Okay. What about associativity? What about associativity? Tell me what about associativity? Whether it is associative or not. We have that group. So we can find out it comes an associative also because product is associative. Product is associative. That's why. In the previous example, the subtraction is not associative.
So means for this we can take any three values. No? So
Yeah, you can do.
-1,
Yeah,
1
yeah, yeah.
I.
Any three value can do the product and you can find out. You will get the same thing. In the previous one, that minus is not associative. But here product is associative. The product is associative. It means this is associative. Okay. Now what about identity elements? Tell me. You can see, you can find out any one
Yes,
row
sir,
or
it is
any one column.
associativity.
Associative is there because product is associative. You can write down like that also. For close also you can write down. For all A and B belongs to V, this implies A dot B also belongs to V. Closed. Now tell me, what is identity? For identity, you need to find out one row or one column, such that that element comes itself. So you can see, if I consider the first column, so that one into that one, I'm getting same element. -1, -1, I, minus I, minus I. So that element is identity. Okay. So identity is equal to 1 is identity. Got it, identity, everyone?
Yes.
Everyone understand identity? Now inverse, you can consider A here, you can consider A inverse here. So you need to find inverse. Inverse is not unique, no. Inverse may be a different quantity. So what we have here, 1, -1, I and minus I. Tell me, what is the inverse of 1? So you need to check 1, this row. So for 1, where you are getting identity, my identity element is 1. So 1 into 1, so inverse of 1 is 1. What about -1? Where I'm getting 1 here. So what is that inverse? Just a little bit up.
-1.
So -1. Are you getting what I'm trying to say? What is I? Inverse of I. Where I'm getting 1, here I'm getting 1. So what is the inverse of I? The inverse of I is minus I.
I.
Correct?
Yeah.
And what is the minus I inverse?
Yes. I.
It is I itself. So whether it is a group, it is group. It is group. Clean and clear, everyone? Anyone, any doubts?
No, sir.
Clear?
So,
So it forms a group. Now I'm going to give you know what is congruent modulo n. So here we define one group. We have 5 minutes left, so we just define, give me a minute. So we define a group called as congruent modulo. We also discuss congruent modulo n. Okay. So tell me, A congruent to B mod n. What is the meaning of that? What is the meaning of that? What is the meaning of that? Yes, we discuss in the group theory, no?
A minus
Yes.
B
B
upon n
N.
is equals to constant.
A
K.
minus B
A-
divided by n, you will get some constant.
K.
Yes or no?
It can
Like
be
that.
any constant, no?
Any constant, any constant. It may be 1, 2, 3, 0, whatever it is constant. The constant is anyone. Okay. Just the point is what? A minus B should divide by n. Okay. So like that only. So for that purpose, we form a one group. So that group is called as, so write down here, that group, this group is called as, so here we define here on Z, when I talked about Z4, suppose Z4, when I talked about Z4, it contains the remainder, it is equivalent to A is congruent to B mod 4. And we are interested in the values of B. So what will be the values of B here? So you can see that B is nothing but the remainder. You can see. Suppose I just take it here. 10 is congruent to 1 mod 3. 10 is congruent to 1 mod 3. So you say that, sir, it is 10 minus 1 is divisible by 3. Am I correct? That is the meaning. You will get some constant. That constant we are not worrying about. Okay. Okay. So meaning of that is what? This is nothing but the remainder. That 1 is nothing but the remainder. If you divide 10 by 3, you are getting that 1 is nothing but the remainder. Okay. So here Z4 is nothing but what are the remainder? So that remainder you just called as tell me any number if I divide by 4, what I will get? What I will get? How many? What are the reminders? What are the reminders? Yes. If you divide 100 by 4, what is reminder? What is the max? Either you will get 0 reminder. Here I called it 0
Yeah.
bar. 1 you will get, either 2 you will get, either 3 I will get. Okay. Suppose I will get 4. I will get 4. It means what? I am getting my again 0. Because what I am trying to say, if I am getting 4, it's congruent to 4 mod 4 is equivalent to 4 is congruent to 0 mod 4. That is what we discuss in the set theory. The both statements are equal, because what is the meaning here? 4 minus 4 is divisible by 4. What is the meaning here? 4 minus 0 is divisible by 4. Whether that two statements are correct? Absolutely, because 0 divided by 4 is always correct and 4 divided by 4 is also always correct.
Sir, but their values will be different, no?
No, that is what I'm trying to say. It is just a representation. Once you represent 2 into 2 is nothing but 4. So either you can represent in that way or you can represent in that way. That is the different representation. The meaning, the statement, it's having same meaning, or the statement have the same meaning. If you divide 4 minus 4, that is correct statement. This is also correct statement. Are you getting what I'm trying to say?
Yes.
Statement are different. I do agree, but the meaning is same. If I write down here, so we are we will discuss this thing in the next lecture also. But I just wanted to say, suppose I just write down here, 15 is congruent to 1 mod 2. Okay, it is correct.
Sir,
Yes.
sir, he actually meant that 0 divided by 4 is equal to 0, right? But 4 divided by 4 is equal to 1.
That constant doesn't
then
matter.
also-
No, constant doesn't matter. It is a constant. What is definition? Okay, I will tell you the definition. See the definition. What is definition? Definition should be it should be some constant k. That's it. That k doesn't matter whether k is 1, 2, 3, 4. It doesn't matter. The meaning is what? Whether a minus b divisible by n. That is the case. Okay, we will discuss that. We will discuss that group in the next lecture. Okay, we will stop here. I request everyone, please put your attendance in the chat box. Okay, so everyone put your attendance in
Means
the
the
chat
value
box.
doesn't matter, only k should come.
Constant term should come.